We're going to find some zeros of a polynomial function. If this is section 3.4. And here we have x to the fourth minus 3x to the third plus 6x squared plus 2x minus 60. And we have been told that 1 plus 3i is already a 0. So let's find another 0. And we know that we have that because 1 minus 3i will also be a 0 because of conjugate pairs, which we had just talked about. So if I were to write this out in linear factors, it would be written this way. X minus, and then inside of here is our factor of 1 plus 3i, and then x minus, and then the conjugate of that, which is 1 minus 3i. We know that those are factors of f. So now if I write them together, I have this, but we need to multiply them out. So if I multiply these out, I know that this times this is what I get for 9i squared. And then I can also multiply this and this together to get this squared. I need to go and actually multiply the first part out. So if I were to do this part right here, I'd have x squared minus 2x plus 1. This one is still minus 9, but remember an I squared is a negative 1. So that becomes a plus 9. The only two things I can combine here is this 1 and this 9 to get a 10. So now I know that I have x squared minus 2x plus 10 as one of my factors of that original polynomial here. So moving ahead. Now, if I do log division and I divide my polynomial by this quadratic, I can find that my another quadratic is x squared minus x minus 6. An example of dividing long division is in section 3.3. So now I know that of that polynomial. I could take this further and factor it further down, and now I have this rational 0, this rational 0, and we know that already 1 and 3i, 1 plus 3i and 1 minus 3i are irrational, not irrational, not real number zeros of the polynomial.